Previously in this course, you learned about using subqueries, which are nothing but an expression that return results to an outer calling query. But what if you wanted to actually use the columns in the inner query just like any other relational table? You can do that by using table expressions. Like subqueries, table expressions are query expressions, but they extend this idea by allowing you to name them and to work with their results as you would work with data in any valid relational table. You will learn how to create simple views and write queries against them, create simple inline table-valued functions and write queries against them, how to write queries that use derived tables, and how to write queries that use CTEs, which are common table expressions. Before we get started with this module, you need to understand that the lifespan of a table expression is limited to the query in which it is defined and invoked. Views and table-valued functions, however, can be stored in a database and reused. A view is a table expression whose definition is stored in a SQL Server database. Like derived tables and CTEs, views are defined with a select statement. Now let's learn more about views and how to use them. In the first lesson, you'll learn how to write queries that return results from views and how to create simple views. A view is a named table expression whose definition is stored as metadata in a SQL Server database. Views can be used as a source for queries in much the same way as tables themselves. However, views do not persistently store data. The definition of views is unpacked at runtime and the source objects are queried. And just like derived tables and CTEs, queries that use views can provide encapsulation and simplification. Apart from modularity and encapsulation, views also provide reusability, and from an administrative perspective, views can provide a security layer to a database, which means that you can use views as a security mechanism to restrict the data available to the end users. In SQL Server, a view represents a virtual table, and just like a real table, a view consists of rows with columns, and you can retrieve data from a view just like you would retrieve data from a real table. You can also use views to join two tables in your database and present the underlying data as if the data were coming from a single table. Views can also aggregate data and help partition data. And when writing a query that uses a view as its data source, you need to use the two-part view name wherever the table source would be used, such as in a from or a join clause. An order by clause is used in this sample syntax to emphasize the point that as a table expression, there is no sort order included in the definition of a view. Now let's take a look at some examples to see how to retrieve data from views. Let's expand T-SQL 2012 database, expand views, and as you can see, there are some views that are already defined in this database. Let's open a new query. Let's expand the customer orders view, and let's do a select customer ID and the order month from sales.custom orders view. Click on execute and the results are displayed here. And as you can notice, there is no way to determine that the from clause references a view and not a table. The similarity between a table and a view provides an important benefit. An application can be written to use views instead of the underlying tables, shielding the application from changes to the tables. As long as the view continues to present the same structure to the calling application, the application will receive consistent results. Now let's take a look at the definition of this view. Let's script this view as alter to a new query editor window. And as you can see, this view gets data from both the orders and the order details table and groups it by the customer ID and the order month. So this view has created a new virtual table by using records from both the orders and order details table. And you could use the view inside of a query from your application or a stored procedure or even from inside another view. Views are a simple but powerful abstraction. You can push query complexity like filter and join statements into a view to to present a simpler model of data without sacrificing the database design or integrity. And as far as administrators are concerned, they can use views as a security layer, granting user permissions to select from a view without providing permissions on the underlying source tables. Now let's see how to create a simple view. We often describe a view as a virtual table because the database does not store the view data. Instead, when we retrieve data from a view, the database engine recreates the data using the select statements in the view definition. Since the database only stores a definition of the view and not the data, there is no significant cost in space for using a view. In order to use views in your queries, the view must be created by a database developer or an administrator with appropriate permissions in the database. Views are defined with a single select statement, and to store a view definition, you need to use the createView tsql statement to name and store this single select statement. And while creating the view, the order by clause is not permitted in the view definition itself unless the view uses a top, offset fetch, or for XML elements. And to sort the output, you need to use the order by in the outer query. This lesson covers the basics of creating views for the purposes of discussion about querying them only, but the view creation itself supports additional options which are beyond the scope of this class. Now, let's take a look at this example. In this query, we are creating a view which is called HR Employee Phone List using employee ID, the last name, first name, and the phone number information from the HR employees. Let's execute this query and see what the results will look like. Let's open a new query. Let's paste the query that we just saw, select it and click on Execute. Let's click on the views and then refresh them. And now you will see the HR Employees List view in the list of views. You need to have a goal in mind when creating a view. There are a number of scenarios where you will want to look for a view as a solution. For example, you may have to hide the complexity of the underlying database schema or customize the data and schema for a set of users. In that scenario, you will want to create a view. The other scenarios may be to control access to rows and columns of data or to aggregate data for performance. Let's take a closer look at each of these scenarios and see how a view is a solution. Taking care of complex joins and filtering rules inside of a view can benefit other users. For example, let's take a look at the sales order values view that's in the T-SQL 2012 database. Let's look at the definition of this view, and you can see that it gets data from the order and order details table. And when you take a closer look at the value column of this view, it's calculated using the quantity, unit price, and the discount columns. And when you have business users with an ad hoc reporting tool, they can take advantage of this view in building customized reports. They can use this view to see all the details about an order without finding the tables to join and without performing the calculation for the value themselves. Not only does this make the database easier for the end user, but it also allows a DBA to make changes to the underlying tables without breaking the end user reports. But you need to take care not to let the number of special case views explode in your database. Although it might be tempting to provide every user a view to meet a specific need, remember that it's possible to select from an existing view and provide additional filtering. A large number of views can be difficult to maintain, especially when changes are required to the underlying schema. Let's take a look at the order totals by year view that we have here. Let's script this view as alter to new query editor window. And as you can see, this view will give the sum of the total quantities broken down by the order year. And if you just wanted to see the quantities that were sold in a particular year, you can do that using a select statement. Let's open a new query and let's do select order year and the quantity from sales order totals by year, where order year equal to 2008. Let's execute this query. Click on execute, and it will give the quantity that was sold in 2008. Next, let's discuss how to use views as a security tool. SQL Server already has the ability to restrict access to a column in a table. However, a view can be a useful tool to provide both column and row level security for a database. Let's say the HR employees table also has salary information. And let's say you denied access to the salary column to a user called Joe. Joe might be confused when he can see the table but has an error appear when his select statement includes the payroll column. A user-friendly solution to this situation is to deny Joe any access to the table but give him access to a view that retrieves data from payroll without the salary information. And that is how you use views as a security tool. Now that you've learned what views are, how to create them, and how to use them, let's learn about inline table valued functions in the next lesson.